In today's class, we'll learn about problems on inverse Laplace transform by the method of partial fractions. The problem is find the inverse Laplace transform of 3s plus 1 whole divided by s minus 1 into s square plus 1. The solution of this problem we'll see now.
Evaluate Laplace inverse of 3s plus 1 whole divided by s minus 1 into s square plus 1. Solution. So the given question, we need to first apply the partial fraction. So here let 3s plus 1 divided by s minus 1 s square plus 1 is equal to a divided by, see here, if you open the bracket, s into s square s cube, total 3 means s cube means we need to apply means we need to find 3 constants here in the Laplace in partial fraction. So first bracket a upon s minus 1, and for the second bracket we can write it as it is bs plus c divided by s square plus 1. For such kind of expression we need to replace the constant as. Okay, so we need to simplify. So LCM, if you take the LCM, we'll get here on the right hand side s minus 1 into s square plus 1, which cancels here. So on simplification it will become 3s plus 1 is equal to a, because the divided by a is what here, s minus 1, which cancels, we'll get here s square plus 1 plus bs plus c into s minus 1, or I can simplify one, or else we'll keep as it is. We'll simplify this now. So put s is equal to 1, put s is equal to 1, what happens we'll see. So which is nothing but, you put s is equal to 1, 3 into 1 is 3, 3 plus 1 is 4 is equal to, so s is equal to 1 square, 1 square is 1, 1 plus 1 is 2, that is 2a plus, so s is 1 means plus 1 minus 1 0, 0 into this entire thing is 0. So therefore we'll get a is equal to 2. Now put s is equal to 0, because we don't have any other option right now, because here if you put s is equal to minus 1, so minus 1 is nothing but plus 1, 1 plus 1 is 2 only, so again we will not get a particular value of any of the constant. So I will put s is equal to 0, what happens we'll see. So 3 into 0 is 0, 0 plus 1 is 1 is equal to 0 plus 1 is 1, 1 into a is a plus b into 0 is 0, so b will become 0 here, c into 0 minus 1 is minus, so minus c it is. So therefore 1 is equal to a minus c, or 1 is equal to, we know the value of a, that is 2 minus c, which implies c equal to 1. So we got the value of a and value of c. So we'll see how to find the value of b now. So we'll see, so to get the value of b, I will compare the coefficients here on comparing the coefficients of s square on both sides. on both side. What we'll get here? So here no s square means 0 is equal to, here a into s square means we'll get a. Next, if you open the bracket, bs into s minus 1, so bs square, but bs into this bracket will get bs square, will get coefficient of s square is plus b. But if you open c into s minus 1, so it will become c into s, which is not a s square. So we got this. So we know the value of a. So 0 is equal to a value is 2 plus b, so which implies b is equal to minus 2. So we got a, b and c. So these values will apply here, and then we'll apply the inverse Laplace transform. So therefore 3s plus 1 divided by s minus 1 s square plus 1 is equal to a value is 2, so 2 divided by s minus 1 plus b value is minus 2 into s, because bs plus c, so minus 2 into s, and c value is what here, 1 divided by s square plus 1. So this we have these values we got from what here, this above, a value we have applied, b value and c value, so we got this expression now. Here we need to go for a small simplification, then we'll apply the inverse Laplace. So that is 2 upon s minus 1, we'll separate it, so minus 2s, so minus 2s divided by s square plus 1, plus into plus is plus, 1 upon s square plus 1. So now it is easily we can apply inverse Laplace. Take inverse Laplace on both sides. 3s plus 1 divided by s minus 1 s square plus 1 is equal to, 2 is a constant, inverse Laplace of 1 by s minus 1 minus 2 times inverse Laplace of s divided by s square plus 1 plus inverse Laplace of 1 by s square plus 1. So in this way we need to apply the inverse, then we need to apply for what here, result of this. So 2 times 1 of inverse Laplace of 1 upon s minus 1 is e raised to t, minus 2 times inverse Laplace of s upon s square plus 1 is nothing but it is cos of t plus inverse Laplace of 1 upon s square plus 1 is nothing but sine of t, 1t divided by 1, so which is nothing but 1 itself. So this is the required solution of our given inverse Laplace transform using partial fraction.